Hello, and thank you for joining us today for our 3-barrel pond filter build. For this build, we will be utilizing three 23-gallon barrels that are 15 inches in diameter and 30 inches in height. Water enters from the right-hand side, filling the first barrel. This barrel is a dual-function filter, with the bottom half acting as a swirl filter and the top acting as a static media bed. Once the first barrel is full, water flows into the second barrel through the rightmost diagonal pipe, filling the second barrel. This barrel again is a dual function filter, with the bottom half acting as a radial flow settler and the top acting as a static media bed. Once this barrel is full, water flows through the second diagonal pipe into the third and final barrel. This barrel is a fluidized moving bed filter. Water exits the final barrel and returns back into the pond or tank. Each of the barrels contains K1 biofilter media. Between the three barrels, 4 cubic feet of K1 media were used. Right barrel, the swirl filter. The first step in the build is to drill all the holes and install the bulkhead fittings. For our barrel filter, we used 1.5-inch ABS pipe throughout. Starting with the rightmost barrel, we have the in-feed piping entering at 90 degrees to the out-feed and drain piping. The first step is to establish some reference marks on the barrel. To do this, we find the center of the barrel and then use a carpenter's square to mark off 2 points that are 90 degrees from each other. Next, we need to measure up 14 inches for the drain and inlet pipes and 20 inches for the outlet. Here we chose to have the inlet and drain at the same height to help support a screen that will be installed to create a separation from the lower swirl filter and the upper static filter within the barrel. We will get into that a little bit later in the video. Once all the locations have been marked, we drill the holes. The size of the holes will depend on the type of fitting you use. In our case, we chose to use bulkhead fittings, but you could also choose to use a uniseal type fitting. After the holes are drilled, clean up any burrs or rough edges with some sandpaper and install the bulkhead fittings. A swirl filter relies on centrifugal action to separate heavy solids out of the water column. Water enters the barrel at a sharp 90 degrees, forcing the water into a cyclone. The heavy solids are forced to the outside of the barrel where they settle to the bottom for easy removal. Now that the first barrel prep is finished, we can move on to the middle barrel. Middle barrel, the radial flow settler. For the middle barrel, all of the holes are lined up vertically with the drain at 6 inches, the inlet at 10 inches, and the outlet at 17 inches respectively. We follow the same steps as the previous barrel, first marking the hole locations, then drilling the holes, and finally installing the fittings. A radial flow settler is very effective at removing the finer solids. We chose to start with a swirl filter to remove the heavier solids and follow that with the radial flow settler to remove the finer solids. Water enters at the center of the settler with a 1.5-inch pipe pointing upwards. From there, the direction of the flow changes to a downward flow as the water enters the larger inverted capped pipe, which you will see later in the video. When the diameter of the pipe increases, the velocity of the water decreases. Now the water is traveling towards the bottom of the barrel. When it exits the larger pipe, it again slows down since it now has a full diameter of the barrel to flow into. The process of slowing down creates turbulent eddies or a radial flow of water, which takes the finer solids held in suspension and directs them towards the outer surface of the barrel. The flow at the outer surface is negligible, and this allows the finer solids to settle to the bottom. Now that the barrel prep is finished, we can move on to the final barrel. The left barrel, the fluidized moving bed filter. For the final barrel, the inlet and the drain lines are lined up vertically, and the outlet is positioned 90 degrees to the inlet and drain. For this barrel, the pipe heights are the same as the middle barrel, with the drain at 6 inches, the inlet at 10 inches, and the outlet at 17 inches respectively. Once again, we follow the same steps as the previous two barrels, first marking the hole locations, then drilling the holes, and finally installing the fittings. A fluidized moving bed filter contains the filter media held in suspension by water that is being constantly circulated. The circulation is produced by a large column of bubbles from an air stone located towards one side on the bottom of the barrel. The action of the media circulating through the water exposes the entire surface area of every piece of media to the flow of water. The column of bubbles oxygenates the water, creating a perfect environment for aerobic bacteria to thrive. The most common media and what we used in our filter is K1 biomedia. The K1 media is designed to have a large surface area to volume ratio. By having the media constantly circulating, you can achieve a surface area of approximately 900 square feet from as little as 1 cubic foot of K1 media. We have included a link below from where we purchased our K1 media. Now that all of the prep work has been completed, let's move on to assembly and glue up. You can see in this picture that the tanks step up as you move from left to right. In our case, we chose to use a 5-inch step. The change in height assists with the flow of water from one tank to the next. Once you are comfortable with the position of your barrels, you can move on to installing all of the piping and related fittings. Your layout will determine the fittings you will need. For the video, we will provide a general walkthrough of our system, but will not get into any of the individual fittings as your system will likely vary from ours. Make sure to use Teflon tape or pipe dope on all the thread fittings to prevent leaks. On the inlet piping from the koi tank, we installed a ball valve in order to control the volume of water flowing through the filters. In the case of swirl and radial flow filters, a slower flow is better. Too high of a flow will keep the solids suspended and they will not settle out of the water. The ball valve is then connected to the pump. All fittings on the exterior of the barrels need to be watertight, so you'll have to use appropriate glue or Teflon tape to secure the fittings. The glue is harmless to your fish once it has cured. Each of the bulkhead fittings will require an adapter which is threaded on one end and has a male or female pipe fitting on the other. Now that the inlet piping is complete, we move on to installing all of the remaining adapter fittings. Again, make sure you use a sufficient amount of Teflon tape or pipe dope. Once all of the piping has been installed, you will not be able to adjust the adapter fittings without cutting your piping if they leak. We just might be telling you this from experience. With the adapters installed, we move on to cutting, dry fitting, and gluing the pipe runs. Here we are doing the final glue up of the pipes that run from the outlet to the inlet of the barrels. Next we move on to plumbing the drains. Each drain is fitted with a ball valve and connects to a common drain line. The ball valves allow each barrel to be cleaned and drained individually. The common drain has a flexible hose attached that can be run to a floor drain for cleaning. On our configuration, we installed a cleanout after the first barrel drain as another connection point to a common drain and hose. We use this when we clean out our other koi tank and filter that's not in this video. Try not to get ahead of yourself. Here I glued the drain line together and forgot to install the last ball valve, so I had to cut the pipe and install the valve later. Now let's move on to the interior plumbing. You don't need to glue any of the interior plumbing, but I do recommend attaching the fittings with a single screw. This holds everything together and it still allows you to make changes or adjustments later. For the first barrel, the inlet pipe does a sharp 90-degree turn and points slightly downwards. This creates the cyclonic circulation for the swirl filter. The drain is piped to the center of the barrel and turns 90 degrees downwards, and then extended to about a 1/4 inch above the bottom of the barrel. The end of the drain line has a screen attached to prevent any media that might make its way into the swirl filter from being discharged during cleaning. The outlet again is plumbed to the center of the barrel and turns 90 degrees upwards and extends to just below the top of the barrel. The pipe extension has slots cut into it to allow water to drain out. We have since installed a conical screen at the top of the extension to act as a weir. This allows us to adjust the height of the water within the barrel. A screen is installed just above the inlet and drained to separate the static media bed from the swirl filter. The middle barrel is plumbed similarly, with the drain turning downwards and extending to the bottom of the barrel. The inlet turns upwards and extends around 6 inches. A 3D printed screen fits over the top of the pipe and sits on the 90-degree fitting. In this case, the screen separates the radial flow settler from the static media bed. Once the screen is installed, a section of 3-inch pipe that transitions to 4-inch pipe is installed over top of the inlet pipe. A cap is installed on the top end of the 3-inch pipe, and a couple of small holes are drilled in to allow the trapped air to escape. This section of pipe is attached to the screen with zip ties to prevent it from moving. The outlet is plumbed to the center of the barrel just above the 3-inch pipe and turns 90 degrees upwards and extends to just below the top of the barrel and is fitted with a conical screen, which we do not show in the video. We have included all of the 3D printer STL files for the screens in the description below. The final barrel has the drain line plumbed once again to the center and turns 90 degrees downwards, extending to just above the bottom of the barrel. The intake is plumbed to the center and turns 90 degrees to the left and points slightly downwards. This has a screen on it as well. The inlet is plumbed to the center and turns upward and is extended to just below the top of the barrel. The extension has slots cut into it for draining, and a screen is installed on the top. An air stone is installed on the bottom of the barrel, and the air hose is run up and over the lip of the barrel. The hose can be installed through the barrel or through the lid if you like. To finish this barrel off, we added the outlet plumbing and directed this back into the pond or tank. Once everything is plumbed, you can do a test run. Let your pump fill the barrels and check and repair any leaks. Once you are leak-free, drain the barrels and add the K1 bio media. If you have time, you can pre-soak the media in a potassium permanganate solution for about a day and then rinse before adding it to the filter barrels. This helps to etch the media and speeds up the bacteria colonization. We added approximately 1.5 cubic feet of media to each of the first 2 barrels and 1 cubic foot of media to the last barrel. Turn on your pump and adjust the flow so none of the barrels are overflowing. An appropriate flow rate for our 23-gallon barrels is around 5 gallons per minute or 300 gallons per hour. Our koi tank is just over 500 gallons, so this will turn over the entire volume every hour and a half or so. The final step is to establish the bacteria in your filter. We always add dry beneficial bacteria to our ponds. The bacteria needs ammonia in order to colonize. If you're not sure how to start your filter, there are a number of videos on YouTube that will walk you through the process. Thanks for watching and good luck with your build. If you have any questions, please leave us a comment below. If you found the video useful, please like and subscribe. Thanks.